Alrighty, let's get started. So you're in Security 403, which has been titled Building AWS Partner Applications Using IAM Roles. As I kind of give a little bit of an intro here, I'm going to be showing you guys code samples today, because that sounds like a great idea, right? This is a 400 level talk. So if you've got your laptop open and you feel like going here, you can take a look at the source code that's not going to be on the screen, which might be easier for you to read. And then I'm also going to be showing an open source project that my company has built and open sourced for building IAM policies in Python. We think it's a little bit better than writing JSON by hand. For any of you who have ever done it and had the whole trailing comma problem, this helps you avoid that. So I come from this company named Bracket Computing. I'm not going to tell you too much of what we do because I don't think most of you actually really care in this talk right now. But I want to give you a little bit of background because I think it's going to help kind of give context for where this talk is coming from. Bracket provides, we allow customers to come to us to sign up for an account. We then provision an Amazon account for them behind the scenes. And then we have this multi-tenant control plane or management plane that sits in front of that, that then acts on behalf of those customers inside of their own individual Amazon accounts. And so this might be familiar to some of you. I think some of you in the audience might be doing very similar things, or basically a customer, either you give them an Amazon account or they come to you with an Amazon account, and you then need to act inside of that. And there are two basic ways to do that, and we're going to talk about one of them. I'm going to call one of them an anti-pattern, and I'm going to show you the other one. So the use cases that we're kind of thinking about here today, cloud management platform is kind of a very simplified version of what Bracket does. We think we do a whole lot more fun stuff than just that, but cloud management platform, managing a cloud, managing other Amazon customer accounts. Log analysis is one that comes up a lot. I talk to a fair number of log analysis vendors, and they want access to our log files. Maybe our log files are in S3, and they come to us, they go, great, generate like an access key for us, and then here's this IAM policy you might use before you generate that access key and the secret access key. That's another kind of use case for what we're talking about today. In general, it's just whenever you need to go talk to another account. You can authenticate with Amazon using one account and then get access to another one. That's what we're talking about today. How many of you, I'm kind of curious, and this is like a 400 talk, and thanks for coming out, by the way. I know most of you really feel like you should probably be taking naps and getting ready for the party tonight. I know I kind of wish I was. It's been a pretty long day. It's 5:30 on Thursday, right? Who went too hard last night? Nobody? That's why you're all here. Yeah. Great. Okay, we can dive right in. Anti-patterns. I consider an anti-pattern, these are things that you probably don't want to do. And I know that there are exceptions to every rule. But in general, asking your customers to generate an access key ID and a secret access key, copy and paste it, put it in some web form, and send it to you, I think what we're going to talk about today is a better way of doing it instead. And really what it comes down to is you have to keep secrets. And keeping secrets is really hard, right? We see where companies have been attacked and been compromised all the time. Sometimes it's credit card numbers, but wow, you're not supposed to store credit card numbers either. Sometimes it's passwords, where they put the passwords into the database instead of hashing them. That's pretty bad. In this case, you do actually need to store what is effectively a username and a password. And maybe you encrypt it, but the keys are probably sitting on the box, right? So keeping secrets is really hard, and so I'm going to show you how to do this without keeping a secret. Another anti-pattern is asking users for too much permission. You give them this sample IAM policy and you say, hey, generate this access key for me, or maybe we're going to do assume role, and you do something like star. I want all the actions. You're asking, potentially, maybe you're a cloud management platform and you actually need access to everything, but we're going to talk a fair bit today, or we're going to weave in least privilege wherever we can. So as we go through this, we're actually going to kind of build a really lame application as we go through this talk, right? It's only 45 minutes, and I've got to show it to you on a big screen. But we're going to actually try to build a small cloud management platform. And so the requirements for this are that we're going to, of course, act within another Amazon account. We want to take on a subset of permissions. This is just the permissions that we require to perform the things that we want to do. And we're going to say we're not going to keep any secrets. We don't trust ourselves to keep secrets. We don't want to be compromised. We don't want to be on a Krebs on security blog post. So how are we going to do this? This talk, really what we're going to do today is a deep dive on assume role. I think we're going to have a bit of fun with it. So this is straight out of the documentation. It returns a set of temporary security credentials. You can use these to access other AWS resources, typically going into someone else's account. Now you can, of course, assume role into your own account. You can use that to, maybe you've got a box running that has a reduced set of privileges, but it can then use assume role to get, use STS, get a set of temporary tokens, take on some other set of functionality. You can do that as well. I don't think I'm going to show that to you today, but it's the same thing. It's just a different trust policy. We'll show you the trust policies today. So what we want to do, or what we're going to do now, I already said we're going to dive in. We're going to dive in again. This is a double dive in right here. We're going to do describe instances example. So given that a customer comes to us with an account ID and a region, we want to be able to go into that region, do a describe instances across those instances, and just print out the instances that are running in their account. So what do we need to do this? I assume most of you actually done assume role or at least looked at it once or twice, so I'm kind of skipping over some details here. But what we need to do is we need to set up an IAM role in the customer account. Obviously, the customer needs to do this the first time. So you're going to be able to provide to them, hey, here's a sample role. Obviously, they have the opportunity to edit it. Hopefully, they don't, but they could. They can also audit it to make sure that you're only taking access to things that they think you need access to. And we also need to establish a trust policy. And so what the customer is going to tell Amazon is, hey, this role that grants this set of permissions, I trust me to assume that role and to take on the permissions that that thing gives. All right, so let's try this out. We're going to press the little button here. Bam. And for those of you in the back, just Mahesh, I hope you can read this code. And like I said, it's on GitHub. So what do I want to show you first? Let's show you the customer half. So this stuff's on GitHub. I'm going to kind of cruise on through it. It's got some documentation in it. I tried to make it so that if you were looking at this after the talk, or maybe you're watching a video, you can go and you can look at the source code and hopefully understand it and learn something from it just by looking at the code instead of having to listen to just me. So here we are. We're generating an IAM policy. This is our access policy. This looks an awful lot like something you might type into the custom policy section of IAM, except this is obviously not a string. It's not JSON. This is Python. This is the AWS library I was telling you about before. We basically map one-to-one. We just give you a little bit of syntax checking. And of course, you can use Python to generate these things. So here's our access policy. It says, I'm going to allow describe instances and create tags across any resource. This is a fairly forgiving policy. We're going to start to lock things down a little bit more as we go here today. And now here's our trust policy. And this is where when the customer creates this access policy, they throw this trust policy on it at the same time. And this says that, hey, Amazon, trust this other account. In this case, I've defined it as CMP account ID. So this is an actual real Amazon account if you guys feel like trying to break into this. Violates somebody's terms of service agreement. So here's an ARN specifying that account ID. This is our trust policy. It says you're allowed to call assume role. And who's allowed to do it? Who's the principal in this case? It's the cloud management platform. It's us. Great. And so when I run this script for you today, we're going to print these things out so you can kind of get a feel for like what AWS is doing. It's actually not a whole lot, but it's still really nice to use. There's also included in GitHub, that I guess is open source now, is this little module called IAM utils. And what we're doing here is, this is a lot simpler than using Botto. Obviously, I'm just wrapping up a bunch of Botto calls to to create this trust policy and to attach that access policy to it. So here today, when I'm running all of these things, you can see that I have two terminals open. This one on the right is for the customer side, and this one over on the left is the CMP, or the cloud management platform. So when I run this, I'm using my customer credentials. So I can just say customer setup, go. And as I told you, it's going to print out the access policy. It's going to print out the trust policy. And here's a little print statement showing that we actually added this thing. That's basically it. So this is the part that your customer is going to do when they sign up for your service. Now we come over to the CMP side. What would we have to do on the CMP? Now we actually want to use this. We've got the CMP. What's the software we've written to actually call assume role? Well, this is it. We need the account ID of the customer. We need to know the name of the role. So when you give that customer that access policy, they need to name it in a particular way. Otherwise, you'll never be able to find it. In this case, we've called it easy describe. We're going to use the STS to get temporary tokens. Given that information, we can put together the ARN of the role that we're going to assume. And then we call, in this case, we're using Botto. We've created an STS connection, and we're going to assume that role. the two required arguments for assume role, and we're going to actually go in pretty deep here on the various requirements to assume role. The first one is the ARN that you're assuming, and the second one is the role session name, and we're going to show you this quite a bit in a little bit and how this applies to auditing, what your customers can see, what you can see when these things show up in, for example, CloudTrail logs. Once we've gotten our assumed role, our temporary credentials, we can then go back to Botto and say, cool, now I want an EC2 connection. I want to go to West 2. Here are my access key, my secret, and my token that came back from assumed role. And once we have that, now we're just in straight up Botto land, right? We have our EC2 connection object, great. It's called get-only instances, which is basically doing describe instances. We're going to loop over those instances, print the ID, and some tag information, why not? What I've also done here is to kind of, when this is executing, I'll show you some of the fun stuff that comes back from that assumed role call. I'm not going to print out any secrets for us today, but here's the access key ID. Your STS, when you call into STS, these things expire. This is the ISO format time for when that thing expires. This is the ARN of the user that you're now acting as inside of that other account, and this is the role ID. And so you get to see what all of those look like when I run this. Sweet. So what did we do? We ran, remember we were going to loop over all of the instances and print the instance IDs. Here's our instance ID. Here are the tags that are attached to that instance currently. We have a name, SEC403 demo machine, created just for this. And a tag named key with a value of value. I got really creative when I was doing this stuff. Access key, here's the expiration again, ISO format time. In UTC, if somebody wants to do the math, it's probably about 30 minutes from now. That's the default value for the expiration. And these are the values for the things that I described a moment ago. So that's describe instances. This is super right. There are, given the sheer number of people in the room, normally there's questions after the fact. But I mean, if you guys want to make this fun, I'm totally willing to make this fun. You guys can raise your hand or just start yelling stuff bam, let's go, let's make this interesting. So if you guys have questions or want to interject, go for it. So far, so good. We'll keep rolling. Great. That was our describe instances example. Where are we going next? We already went to the console. Assume role parameters. Here we go. We're going into all of them. Here are 4, and then I think we're going to talk about 2 or 3 other ones in extreme depth. So the easy ones, the ones that are totally obvious, you read the docs, you get it, right? So the duration, you pass in a duration. This is how long those temporary credentials that you get back are going to be valid for. The minimum time is 15 minutes. The maximum time is an hour. On the maximum time, there's nothing I can do to help you. If you need them longer than an hour, you're just going to have to call assume role again. Bracket, of course, has to do this. We have this control plane. It's continuously running. It's continuously acting on behalf of customers. We look at the expiration time on the credentials. If we think they're about to expire, I think the threshold is 2 minutes. We assume, well, it would be pretty bad if we were halfway through some transaction or through some operation, all of a sudden our credentials expired. So we consider 2 minutes a threshold, and at that point we start renewing credentials instead of using them. Something to consider if you are bumping up against the end of your expiration time. If you want to go shorter than 900 seconds, Amazon won't do it for you. But I'm going to show you an example towards the end here where you can tell Amazon, this policy is valid so long as the time is less than this time. Now, you've got to trust your clock, and you've got to trust that Amazon's clock is in sync with yours. But you might also know that TLS, for example, doesn't work if clocks aren't correct. So you can rest assured your clock is probably kind of accurate. But you can actually make this go shorter. I'm going to give you an example where we have credentials for 2 minutes instead of 15 minutes. The role ARN, I showed you it in that last example. You've got to build an ARN that effectively, the key pieces of information there are the customer ID and the name of the role that you're assuming. If you're doing MFA, you need to tell Amazon which MFA you're using. If you've got a Gemalto, right, you saw them down in the Expo Center today, you need the serial number of your Gemalto, and you need the code that's currently on the screen. If you're using Google Authenticator, it's the current code. And you need to give the ARN. The ARN is pretty straightforward. Okay, so now we're going to have more fun with these parameters. The policy parameter you can pass in. What you're able to do here is to actually step down your permissions. When a customer created that access policy, initially you handed it to them, you said, great, these are all the things I need to do. But maybe when you actually go to call assume role, maybe you're a cloud management platform. You need the ability to launch instances from time to time. But maybe this time, the call you're about to make, all you're going to do is describe instances. When we think about least privilege, when we think about where those credentials cached, and we think about what could happen in the event of a compromise. Of course, nobody wants to be compromised. We never think it'll happen to us. But what if? So in this case, what you can do when you call assume role is you can pass in an additional policy that's going to say, these are the credentials that I actually want. Now, you can only step down. You can't step up. Of course, that'd be like violating some trust with your customers. But you can reduce your set of privileges such that those credentials, you limit what can happen if an attacker gets a hold of them. I think I covered this. And we have an example. Who's excited for this example? Yes, yes! Everybody loves to see code. I like you guys are getting into this. Go, Ben, go. Dude in the pink shirt. Yes. You know, and so that's an interesting question. At Bracket, we don't. Okay, so I'm going to repeat the question. Ben's basically asking, when you go to set up access policies, I've just kind of said your customer does this, and I've left it as an exercise for the audience to figure out how to tell your customer how to do that. And that's basically what it is. At Bracket, because we control the customer account in addition to the Bracket account, we're able to initially, and we don't actually do this after the initial bootstrapping, but we're able to initially log into one of those accounts using Botto and some scripts. It's all automated, of course, and create these access policies, establish trust back to the main production account. That's what we're able to do. If you're in that same situation, I would recommend doing that. If you're not and you have real customers, maybe you are that log analysis company, you've got the free trial, you sign up, building a set of instructions that show your customers how to set up the access policies, where to put in the trust policy. I've seen vendors or other Amazon partners that do that. That's certainly an option. If you had a customer that were a little more savvy and maybe you were pretty sure they had Python and Botto installed, then you could give them a Python script that would do it like the one I wrote here and set it up automatically. I guess kind of the options are somewhat limitless. It's just how much work do you want to do? How savvy is your customer base? Are they capable of running scripts? Are they capable of writing scripts? Or do you just need to teach them how to log into the console real quick? And I think it depends on, it varies based on your customer. And potentially if your customer base is very diverse, maybe you can give them all three options. Kind of depends. Yes. We're always thinking about least privilege. Yes. What's the least amount of privilege we need to perform the operation we're going to do? Obviously, you guys need to consider performance requirements. How often am I calling assume role? Every single time I do it, I call assume role and do a step-down policy for exactly what I'm about to do on the next line of code. That's probably not going to scale. You're probably not actually providing any security benefit there either. Now all you're doing is managing lots of credentials, and that's not very fun. Okay. Clear these out. So now we're running on the second stage. I've named these things so that I can't possibly mess up, right? So for number 2 here, all we're going to look at is CMP usage. We already set up the customer side of the account. We're going to use the roles that we set up already. Cool. Some of this should look really familiar. We define, what do you need to call assume role? Well, you need to have the customer ID. You need to have the name of the role that you're doing. We assemble this into an ARN. We create an STS connection. Pretty straightforward. I told you we were going to do something where we're going to make our policy, instead of having that minimum of 15 minutes, in this case, we're actually making it 2. And so we do a little bit of math here where we tell Python to put together an ISO formatted string, except Python doesn't actually know what ISO format is, so we have to manually append the Z to the end. We're going to put together an ISO formatted time string, and we're going to tell Amazon down here in our access policy, our step down policy, you can do all of the things in this policy so long as the date, the current time, is less than the time I'm giving you. So I'm going to assemble this date or this timestamp. I'm going to say it's 2 minutes in the future. This policy only works if we're within that 2-minute period. And the gist of what we're trying to do in this example is we're going to try to tag an instance. Pretty straightforward. You saw when we set up that initial customer policy, it had 2 permissions. One was describe instances, the other was called create tags. What we're going to do in our step-down policy to kind of prove to you that this stuff works is we're going to take away our ability to call create tags, and then we're going to try to set tags. And what do you think is going to happen, right? This demo is going to go off without a hitch. We're going to get an unauthorized operation. Yep. And that's what's going to happen in this case when we catch that exception coming out of Boto. We're going to print out that we were unable to set the tags. Then we're going to go and we're going to call assume role. So that was where here we're doing assume role with the reduced access policy. Great. Here we're calling assume role, taking on the full policy. We're going to call that same function again, create tags. We're going to see that it actually worked. I'd ask you guys to bet me. That'd be kind of fun, right? Could step this up a little bit. Totally kidding. Anyway, exactly what I said was going to happen. We tried with the reduced privileges, unauthorized operation. We weren't able to set the tags. Now we're trying with the full privileges, and it worked. You can see that I kind of cheated. I've been running this all day, making sure that it's actually going to work, and so I forgot to clear the tags on this instance before the demo. That's why you see it in both cases. You could actually run these scripts yourself if you wanted to. You'd probably just have to change the Amazon IDs. Yeah?
Have you ever run into issues with timeouts or doing the assume role and you're executing it right away when you're trying to get the customer environment, and then the assume role, that's the case without gone through yet, and so the next fails?
Kind of like an eventually consistent kind of operation. So you have creds, and then you go back to Amazon, and they say, never mind.
Well, you do the initial assume role, but you have to, anytime you issues,
Yeah. I think I understand. So the gist of it would be you would call assume role, you get back that 3 tuple of credential information. On the next line, you'd create that EC2 connection object. You maybe go to call describe instances, and Amazon comes back and says, these credentials are invalid. I've never seen them before. Yeah, it's really interesting you ask that question. I don't think that it's generally a problem for us. We've probably seen it. I have a feeling that we have, and it kind of just falls into the noise for us. Yeah. It wouldn't surprise me at all, kind of given the distributed nature of how Amazon does everything that they do, that there is potential for a little bit of latency there. IAM being one of the services that's usually pretty tight. Wouldn't surprise me at all. We probably have seen it. We don't generally run into it. It's not generally a problem for us because we're caching the credentials. So we cache them in memory. So what we do is we go off and we ask Amazon for 60-minute creds, because that's as long as they'll let us go. Although 60 minutes seems like a pretty good number anyway. We go off and we ask them for 60-minute creds. We store them in, we're a Python shop on the control plane. So we're going to store them in a Python dictionary. We've got a fun little data structure that's going to help us keep track of when credentials are about to expire and kind of like behind the scenes go back and get new creds. So that's something that we've done to, so if you get it the first time, it'll work the second time is kind of what's happening for us. No, but I'm going to show you at the very end when we put all this together where we're using so we're an Amazon shop as well, so our control plane is all running on Amazon. We're using EC2 instance profiles to specify, and we're multi-tenant as well. So the service nodes that are going to be calling assume role need the ability to do it across all of our customers. So actually we're in the customer ID field for, I'll show you that policy. You'll see where we grant assume role access to ourselves. The next parameter that we're going to kind of dive into is role session name. And this one you would think is kind of fairly boring, right? You've seen in my example so far, I just kept typing in like SEC403 demo, or this is the role session name. It's actually really fun. So there are some limitations here, and you can read those all by yourself. But the real fun part is that this is useful for auditing. It's going to show up in your CloudTrail logs in 2 different places. One of the things where we use this, so let's kind of step away from our CMP example for a moment and pretend maybe you have some other kind of application where you take in, users come to your platform, whatever it may be, and maybe it's just a script that your operations staff are running. They've authenticated with that somehow, maybe against an Active Directory server, an LDAP server, whatever. And you have user identity information at that point. Then you call assume role and you start acting inside of that Amazon account and you've lost that identity information. One of the things you can do is you can take like the user ID that you got from your LDAP thing. When you call assume role, you can make the role session name contain that user ID. And now all of a sudden you have kind of like this continuity. When you get into your audit logs, you get into CloudTrail and you're saying like, who called describe instance, create tags, or did whatever it was that was granted by the assume role call. You're gonna be able to see who is actually doing it without having to really unwind or like artificially generate logs in some way. So we do that. So staying with role session name, where does it appear? So if you've got CloudTrail enabled in your account, you're calling assume role. Of course, CloudTrail is logging the fact that you called assume role, and it shows all the parameters that you passed into the assume role call. Role session name, hi mom. Hi mom is the example here. Now what's happening inside of your customer account? So you have this user identity, which is an ARN that says, and you can, the ellipsis there is really truncated. There's more stuff in there that I didn't think was important. The role name that you assumed, I think in our case, so far we've been using something called easy describe, so it would be easy describe there for role name. And then the hi mom part, that's the role session name. So when you type something in here, just the joke I like to tell people is when you put a role session name in there, maybe one of your customers has been misbehaving and you're mad at them and you type in something mean about your customer to say this is the role session name. We would never do this. You shouldn't either. Just your customer can see it, be careful. It does show up in both places. That's kind of what I'm trying to tell you. And auditing, this is just a further example of what's coming out of CloudTrail. It's going to tell you at what time, what role was being used, again, the role session name. So when you're auditing things, you can go through. We do, depending on the tool that was being used, in this case, you see the prefixes admin hub or ADM hub. It stands for admin and hub. That's kind of the name of the application that was doing stuff, and then the username of the person that was actually performing that operation. I've kind of blanked out the customer, the Amazon IDs in this case, but everything else here is straight out of CloudTrail. We're a Sumo Logic shop. I don't know if any else of you are. This is, and you're just gonna have to paste this out of the slides if they get posted somewhere. If you're a Sumo Logic shop and you wanna look in your CloudTrail logs, this is one of the things that we do to kind of parse those out, and you can have fun with this as well. AWS Eagle, of course, was the code name for CloudTrail before it got launched last year at reInvent, I think it was. All right, external ID, this is gonna be a really fun one. External ID is a pre-shared secret between you and your customer. And it's used to prevent what Amazon and security researchers would call the confused deputy problem. What is a confused deputy? It's a computer program that is innocently fooled by some other party into misusing its authority. So let's do this. Let's confuse the deputy. Assume that we're building this cloud management platform that we've been talking about so far today. And the difference, so I've talked a little bit about Bracket. Bracket controls the customer account. This problem actually doesn't apply to Bracket. But if you are one of those one of those log analysis platforms or something else where a customer brings their own Amazon account to you, this is really important. You want to really make sure you're using external ID. You want to make sure you're using it correctly. I'm going to try to walk you through it. So imagine you've got this cloud management platform where customers bring their own Amazon account. They come to you, they fill out their name, their email address, and they paste in their 12-digit Amazon account ID. Great, this is pretty straightforward. Unfortunately, at this point, once we click the go button, we're busted. But you click the go button, great. And now all of a sudden you show the customer, and these are the instructions that Ben was asking about earlier. Here are your instructions. Thanks for signing up. Go log into your account. Use this as the access policy. Amazon's going to prompt you for a 12-digit ID. Paste this one in. Right? This is a very succinct version of those instructions. I wouldn't recommend using these for your customers. The gist of it, the key thing here is that I've said to leave the external ID field blank. This is where now we've officially confused the deputy. I went and I found this picture in the public domain so that I was allowed to use it here today in this presentation. There's a deputy, he's confused. Just like in all the episodes, right? Yeah? Yeah, good. All right, so we've been owned. So at this point, what's possible is that an attacker, the gist of it. We never authenticated that the person providing that 12-digit Amazon ID actually owned or was in control of that account. And so what can happen is maybe one of your legitimate customers comes along, signs up, gives you your 12-digit ID, goes through the process of creating the access policy and setting up trust. They're all set to trust you. That's great. Now they log into your platform and they perform all these operations using the functionality that you provide. Great. Now the attacker comes along. All the attacker needs to do to compromise that customer via your platform is determine the 12-digit ID of the customer. Now these aren't generally regarded as secrets. I was allowed to put them in the slides. Those are real account IDs I've been using today, right? Amazon doesn't treat those as secrets. We're allowed to kind of talk about them. It's highly probable that this could be stolen, I guess is my point. An attacker comes along, provides somebody else's Amazon account ID. We don't validate that they actually own that account ID, and now all of a sudden our platform is giving access to this attacker down into someone else's Amazon account. This is kind of funny, right? This is actually reasonably difficult to explain, I think. Is this making sense to you guys? Maybe? Maybe. I guess the gist of it, the crux of it is that we need to authenticate that the person coming to us actually owns that account. Because if we don't, we can be confused as a deputy into granting access to that account to somebody that shouldn't have access to that account. Basically, the person that actually controls that account set up all this trust and says, oh, you're this cloud management platform or this log analysis platform. I totally trust you guys to go look at all my log files. And I trust that you're going to properly protect access to that you're not going to become compromised. But if we're not using external ID, and I'll show you how to use it in a second, then we're allowing anyone to come along with any 12-digit ID that has already signed up for our service. That's the one prerequisite. And we just grant them access. As another way you can almost solve this problem, if you imagine that when a customer signs up, they give you that 12-digit ID, maybe you're using just a standard relational database, you put a unique on the Amazon ID. Right now what you've done is you've said, well, only the first person to come along. I wouldn't recommend doing that. We should just use external ID. That's the best practice. But you can kind of imagine, like, as that as a potential solution, maybe that helps illustrate what the problem actually is. So what went wrong? We never verified that they actually owned the account. Okay, so how do we avoid confusing ourselves or confusing the deputy? So all I've done, we have that same form in the beginning that says, give me your name, your email address, and your 12-digit account ID. Great. The difference is that in our instructions, we generate, in this case I used a UUID or UUID version 4 for those of you that really care. You can validate it, it's a real one. We just generate some random stuff. And we give that to the customer. Now what the customer needs to do is they need to take that external ID and give it to Amazon. And what this is actually doing, if any of you have ever set up like Google Sites or something like that, where they say, well, you need to verify their webmaster tools. You need to verify that you actually own this domain before we allow you to like control the SEO around it. It's very, very similar. So we're going to ask our customers to take that random bit, in our case a UUID, well, 128 bits, and put it down in there to prove that they own the account. So now what's going to happen is that when we call assume role, we need to pass in that external ID. So we generated that UUID, we're storing it in a database somewhere. We call assume role, we generate the role ARN that contains the customer ID, we know the role that we want to assume, and then we also toss in that external ID. And that's saying that only if the person that actually owned that account and that had the ability to create this role and to set up the trust and to paste in that same external ID that we have, we know we're talking to the right one. The attacker comes along, let's go through that same scenario. The attacker comes along, signs up for the service, pastes in the wrong 12-digit account ID. We generate a brand new, unique external ID. Now when we call assume role to try to get into that other account that they're not supposed to have access to, we use the wrong external ID. Amazon says, no, you don't have access to do this. That's how this is working to prevent the attack. And yeah. No, so when they log in, assuming that, and I'm kind of imagining all this in my head, I know it's not totally explicit. Imagine you have like a row in the database that's kind of like a customer ID and then this external ID. And so when the customer comes in and authenticates, maybe you've got like a session cookie that stores the session or the customer ID. You go to the database, you exchange the session ID for the external ID. So that's still going to work if the correct customer is logged in. We go to grab that external ID, we get the right one. Versus when the attacker comes in and logs in, their customer ID is associated with a different external ID, the assume role call fails. It's a little tricky. The good news is, if you guys want to like run through this on your own, this example that we're going to show next, as we also kind of slide into a slightly different topic, is going to show how we use external ID. You could then take this code sample and play with it and try to understand further. It's a tricky concept to explain, and then once you get it, you're like, oh yeah, it's totally obvious, which is why I'm actually having kind of struggled a little bit to explain it to you guys. The external ID, it's not so much a secret as that the customer is not allowed to control it. So it could be public. It could be public information. What needs to not be allowed is that if the attacker discovers that external ID and can somehow change in your platform that this customer ID has this external ID. So if the attacker's customer ID could be associated with the correct external ID, that would be bad. And that's why kind of one of the key pieces of this is that you as the CMP need to generate the external ID. You can't let the customer choose it. Like, don't let them type in their mother's maiden name or something like that. Okay, so now we're going to go, earlier I said we were going to talk about EC2 instance profiles and how we call assume role. This is where we're going to do it. And we're going to talk, we're putting all this together. It's going to be amazing. Ready? Yeah. I'm trying to have a little bit of fun. Jeez, don't do that. We're going to build our cloud management platform on AWS. We're going to use EC2 instance profiles. How many of you guys and girls are using EC2 instance profiles? 1, 2, 3, probably some others that just don't feel like raising their hand because who wants to raise their hand at a conference? And the other thing we're going to look at here is something that I like to do that I think is a good best practice is to, the closer you are to the edge of the internet, the closer you are to an unprivileged attacker, the fewer privilege you want associated with that. So if I'm developing kind of like a standard architecture in Amazon and I've got my ELB up there, going into a web server, auto-scaling group, there's some other load balancer that's in front of my app tier, dropping messages into SQS, further isolating them away from worker nodes, right? On the left side of this diagram, we want to not have much privilege, right? The ability to call assume role from your web server into any of your customer accounts and take on any access. If we look at like the number of attacks that occur on the internet, especially the publicized ones, it's like, oh, well, it was the vulnerability in the web application, and then like they got root somehow. Okay, so if you root your web server and it has EC2 instance profiles and it's allowed to call assume role, that's bad. Your web application is now gating all of the functionality that's behind it. It kind of like sidesteps all of the controls you've potentially put into your web application. Your app tier, in this case, what we're going to show you is that the app tier has a little bit more privilege, and this is a fairly contrived example to kind of make this fit into some slides. The app tier has a little bit more privilege, and then you go behind SQS where you think you've got like serialized data. It's going to be really hard for an attacker to do fun things behind a queue. The workers then get all of the privilege. And bam, we're going back to some code. I know you guys get really excited when we go to the code, so you got to contain it for a little bit. We're almost done though. We got 8 minutes left. What does the customer have to do? Again, there's a little bit of documentation, so you guys can, if you're not completely keeping up with me, you can come back and look at this later. I tried to document it. It's in GitHub. You could send me messages that say, dude, I don't understand what you were talking about. Tell me more. I'd be happy to help you guys out. We're going to generate 2 policies. One's a read-only access policy. It's allowed to call describe instances. This is a modify instances policy. You can start and stop instances. We're going to build a really basic application here that's not going to use a queue, but we're going to pretend that it does, that's able to start and stop instances. And then here is a trust policy. And so here's where we're using, this is how the trust policy is actually encoded. If you go to Amazon and kind of like run through the GUI, it's just going to ask you, paste in the external ID. What they're actually doing for you behind the scenes is generating a trust policy that looks like this. Condition, string equals external ID, the random thing that we generated. This is where we set up those 2 policies inside of the customer account. So if we call this customer setup, it worked. There's 2 pieces to do on the CMP side. One is the EC2 instance profiles. And I put a lot of docs in here because I'm reasonably passionate about this part, so I typed more. We're going to do, we have 2 different access policies. I'll talk about the app tier first, even though it falls down here lower. We're going to say that the app tier, so what the app tier was going to do is it was going to be able to describe instances, so it needs to be able to call assume role and get that read-only access policy. It also needs to be able to generate messages and drop them into the queue, so it needs to be able to send a message into the SQS. And we're limiting it. It's not just that you can call send message anywhere you want. We're saying you can only do it against the queue we've specified up above. Great. Worker access policy needs a little bit more permission. We're going to say that it is allowed to call assume role, but against the modify instances role. So this is where we're saying further down you go, the more access you're allowed to get when you call assume role, and this is how we enforce that. You're also allowed to call receive message against SQS, against the queue that we specified here. Sweet. And we create those policies. Sweet. Then putting it all together and actually calling assume role, and we just got really short, and I guess I got lazy. Here's where this is kind of like that database row that I talked about before. This is the customer ID. We're mapping it to the external ID that we generated before, so that when we call assume role, we're doing that right here. We know which external ID to use. We get our credentials. We generate an EC2 connection, and we're going to stop that instance. Made this really short so it fits. And we stopped it. I could show you that in the console if you really wanted to see it. I don't think that's all that valuable. That is all I wanted to show you guys. Do you have any questions on this? The second half, and then I can flip over and show you my... That's the end. You guys have any more questions? I'll also hang around afterwards, so if you don't want to yell and have it be recorded through the microphone, I can talk to you independently. Great, thanks guys.